In 1969, a working trolleybus museum was established on 4 derelict acres of former World War II airfield at Sandtoft near Doncaster. Over time, various buildings were constructed to provide workshops, an exhibition hall and convivial facilities to welcome visitors for the experience of riding in these superbly restored electric buses. The museum's extensive collection of historical trolleybuses includes vehicles from Britain and examples of overseas types. Superbly turned out is the former Huddersfield trolleybus number 619. The bus was built in 1956 and its restored condition is testament to the high standards of work achieved by the museum's workshops. Number 425 is a 1932 manufactured single-deck trolley from Liège in Belgium. The conductor has alighted to operate the overhead wiring points, allowing the vehicle to steer round to the passenger pickup bay. This Lancia double-deck bus dates to 1967 and was operated in the Portuguese city of Porto. This attractive Berliet Vetra trolleybus was built in 1943 and operated in the French city of Limoges, which still has a modern trolleybus system. Again, the conductor manually operates the overhead contactor points. Former Derby Corporation Sunbeam number 172 was built in 1944 and is preserved in wartime livery. Bradford was Britain's last operator of the trolleybus, and the museum has a number of their vehicles in their collection. Number 792 was supplied in 1944 to Darlington as a single-deck trolley, but later it was sold to Bradford, where it was fitted with this East Lancashire coach builder's double-deck body. It was withdrawn just months before closure of the trolleybus services in 1972. Number 844 was Bradford and Britain's last trolleybus to operate on the final day of operation, Sunday the 26th of March 1972. Peter Huntington was a conductor on the Bradford trolleys. Peter recollects on those times.
I worked on Bradford buses in 1968, initially out of Bowling Depot. Bowling Depot was a motor bus depot, but when I worked over, I usually finished up working on a trolleybus. Trolleybuses, of course, being all electric, were clean and were very, very swift. unlike the diesel buses. Diesel bus fumes were absolutely terrible. But it was really hard work on the routes that I got. I usually finished up on number 8 Duckworth Lane, which is a short 2-mile route out of Bradford centre up to the infirmary. That route was constantly busy, and there's times when, because of the swift acceleration between the stops, you didn't always have time to actually collect all the fares. At that point I used to shout out, "Any more fares please," hoping that somebody would stick their hand up clutching the money.
A Rotherham Corporation trolleybus, in a typical state of neglect, awaits the attention of the skilled restorers at Sandtoft Museum. Major bodywork repairs and reconstruction are undertaken. Mechanical restoration includes the bus's electrical components, such as the resistor assemblies seen here. The most obvious external difference between a trolleybus and a motorbus is the gear on the roof that collects the electric current. Let's go up and have a look. The overhead contact wires are suspended from span wires strung across the roadway and supported on roadside poles. The roof-mounted collectors have trolley shoes which slide along the contact wires to connect to the electricity for powering the traction motor beneath the bus. Where the bus has to deviate from the main route to turn a corner or pull into a loading bay, the trolley shoes have to be directed onto a contactor wire leading off in the new direction. This requires point work at junctions. In this case, manually operated points on the overhead deflects the shoe onto the diversion. The trolley shoes are held up to the contact wire by springs at the base of the collectors. But how is a trolleybus powered? The power supply starts as standard AC current drawn from the power station. This is at high voltage and so has to be reduced through a transformer. Then it is rectified to DC at around 550 volts. This was done with a large mercury arc rectifier. Looking like something from another planet, these rectifiers were the only thing available at the time to convert AC to DC in the high currents required by the trolleybuses. They could supply 1000 amps if necessary. Once at the right voltage and rectified, the supply is switched in a substation through to the overhead lines. Here at Sandtoft, this is a simple circuit breaker. The feed is then generally underground to section boxes close to the route. Inside were switches to enable sections of the overhead to be switched off for maintenance, or if there was a problem within the section, so that the rest of the system could continue operating. From the section boxes, cables carry the current to the overhead wires. Insulators in the wires enabled sections to be isolated from each other. The line is shown to be live or on by lights. So now the overhead is live, what next? The trolleybus's poles or booms on the roof have to be connected to it. This is done by using a long bamboo pole which is stored on the trolleybus, usually, at any rate in the UK, or the more modern method of trolley receiver ropes attached to the back, which is seen on the continent and elsewhere. The booms are held up by powerful springs on the swivelling trolley bases on the roof of the vehicle. Now the trolleybus has connection to its power source, it must be switched on in order to drive it. The driver switches the main circuit breakers to the on position. Forward drive is engaged on the master controller. The accelerator pedal operates the contactors, which switch the DC supply through resistances and then onto the traction motor. The air brakes are similarly operated through electrical contactors. The contactors bring various resistances into circuit, which control the speed of the motor. Finally, the current arrives at the motor. The motor drives a propeller shaft and a differential in much the same way as a motor bus. This drives the bus along. Note that there is no gearbox, as a large DC electric motor like this can cope with the variations of speed from starting to doing over 40 miles per hour. The constant chatter of the contactors is in response to the application and release of pressure on the accelerator pedal in order to maintain a steady speed around the demonstration track. Approaching a white line across the roadway indicates the beginning of a dead spot in the overhead, and the driver must lift off the power to avoid a flashover. An audible warning confirms the dead spot is passed. So, to end this visit to the Trolleybus Museum, we will join the passengers on board Huddersfield Trolleybus number 619 for a full journey around the museum's demonstration roadway and experience this emission-free form of transport, which was once a common sight in many of our cities. Huddersfield Trolleybus number 619 was manufactured by the British United Traction Company in 1956. The bodywork was provided by East Lancashire Coach Builders. It entered service in January 1957 and was withdrawn in May 1968, shortly before the Huddersfield system closed in that year. Regulations at the time of manufacture required the 72-seater bus to have a 3-axle chassis. .619 is based at the Sandtoft Museum, but is privately owned.